Hey you guys, so what we're going to look at today is putting together all four variables that affect our trig or our circular functions, our graphs. So we have A, B, C, and D. So what I have in front of you right now is just the very general view of what you could see. Not all four will always be there in terms of you need to make a shift, but just so you can see it, I have everything listed. So when you look at A, you take the absolute value of it, that's the amplitude. So if it's A, if it's negative, then we'll reflect it across the x-axis. We'll worry about that later. We'll do an example of that. Now for B, absolute value of B, that's the number of cycles it makes in 2 pi or 360 degrees. The big thing for you guys to see is that the period is equal to 2 pi over the absolute value of B, or 360 degrees over absolute value of B. And we'll get some practice with that. C, we said that is the number that's outside. That's our vertical shift up or down. And then D, that's the one inside, number inside, that's going to be our phase shift left or right. And we'll get, again, more specifics tomorrow. So let's go ahead and actually take a look at how we can put all this together. Okay, so in our first example here, we have y equals 3 plus 4 cosine of 5 times the quantity theta minus 10. So a lot going on here. What I want to do first is just go through and make sure you guys understand which number is set up with which letter. So we have our C, that's our 3. Our A, that's our amplitude, is 4. B is 5, and D is 10. Okay, that's actually going to be a shift right 10 because it's set up x minus D. So x minus D, so D must be 10. Okay, so when you're drawing these, we're going to, draw our first plane axis here. There we go. And you guys could definitely do this too. It's not gonna hurt you. Participating is better than just sitting there. Okay, so great. There we go. Now, step 1, and you're going to want to write all these down too. The first thing you're going to do is draw your sinusoidal axis. So that's basically our new trig axis that we have. Okay, so we're going to draw it at y equals 3, and why we're going to draw it at y equals 3 is because that's my C value, so it's being shifted up 3. So here I go. 1, 2, 3, 1, 2, 3, and I'm going to make it in a different color. That way it's easy for me to see. Sometimes I'll also make little waves over it just to show that it's different. All right, the second thing that we're going to do is draw our upper and lower bounds by going 4 units above and 4 units below the sinusoidal axis. And we get that 4 from our A, that's our amplitude. So if I have my sinusoidal axis at 3, going 4 units above would be 1, 2, 3, 4. We have a 7. I think go down 4, 1, 2, 3. We have negative 1. Now, to draw in the bounds, I just used dashed lines. So there we go. Okay, the third thing we're going to do is we're going to find the starting point of the cycle. So with that, you need to think of, okay, well, cosine graph would start at 0, 1, but now it's being shifted. Look at the D here. It's being shifted 10 degrees to the right. So where would that starting point be? So let's go ahead and write. So when I would plot that, I would go over 10 degrees of my sinusoidal axis, the new one, the blue one. And now remember that cosine starts at a high point. So since I'm starting at 10 degrees, a high point obviously is going to be my upper bound, or up here at the 7. Now to figure out where I'm going to end it, obviously I'm going to end it, it's going to be up here somewhere again, because you need to end up in the same position on the y-axis where you start. But you need to figure out, well, how many do I go? You cannot just assume that it's, you add 360 and then we're done at 370 here. Because the period is going to be different because I see that we have a B value here of 5, which actually means that this graph that we're going to draw is going 5 times faster than the parent function, the cosine function, would go. So obviously it's going to be a lot less than 360 degrees for a rotation. So that is our fourth step, find the period. of the function. And I gave you a little hint up above that we can represent the period of the function. We're looking at degrees here, so we're going to use 360 over the absolute value of b. Okay, well, 360 degrees over b, an absolute value obviously is going to be 5. We have 72 degrees. So that means from 10 degrees, add 72 to that, and I'll be done. Well, 72 plus 10 is obviously 82 degrees. Okay, so go ahead, you know that that's going to be the endpoint, and then I'll write that again. Endpoint at 10 plus 72, so all degrees, which is 82 degrees. All right. From here, we need to figure out what is going on in between. So we know that we have halfway points. So step 5 is going to be to find the halfway point between each of them, because we know that there's going to be a low point halfway between our two highs. So if we take 72, which is our period, 72 degrees, and divide that by 2, you're going to get 36 degrees. Okay, so you could either add 36 to the 10 degrees, or you could subtract 36 from 82. You're going to get that middle point of 46 degrees. So now let's go up here, and halfway, put your 46 degrees. And again, we said that that was a low point. So here we go on our lower bound, so our lower dashed line, that's our low point. So you guys can kind of see already there's the dip. Now, to be very precise, we want to see where it crosses the sinusoidal axis. So then if you look in the graph, halfway between our high and low point, each high and low point, it's going to cross the sinusoidal axis. And where is it going to cross? Well, it's going to cross exactly halfway between 10 and 46. Well, if you do, 46 minus 10, divide that by 2, you're going to get 18 degrees. So 18 degrees here, and then you can add 18 degrees here, and that's where it's going to cross the sinusoidal axis. So I'm going to jot that down, then I'm going to graph it. Okay, so if you add 18 to 10, you are going to get, let's go back up here, you're going to get 28 degrees. So it's going to cross there, so you can make a point. And if you add 18 to 46, you're going to get 64 degrees. So it's going to cross there. Voila. Last step is just to complete the graph. So you know that it is going, I'm so bad at this, going down and up, and then I always want you guys to kind of continue it, just show that with a dashed line. And there we go. All right, you've done your first one. Now in moving on, in example 2, I'm not going to write as much as I did this first one. You can always come back to it. You guys can print out the notes. I'm going to make just a regular PDF so you can copy and follow along if you want and had to have them. I'll put that on the website tonight. But I want you just to, kind of think about what's going on. Think about the steps, and moving forward. So here we go. Example 2. Moving a little bit faster, this one. Okay, we have our equation right here. It looks like we're in radians, so I labeled the x's accordingly. All right, step 1 is to write the sinusoidal, or draw in, I should say, axis. Okay, and for that one, you're going to look at your value out in front here. Okay, you're going to look at y equals 2. So the whole thing is being shifted up 2. So 1, 2. So there's my new axis. I'm going to go ahead and pick a different color to draw that in. Okay, fantastic. Now from here, let's pick the upper and lower bounds and draw them in. For that, you're going to look at your amplitude out in front. So you're going to go 6 above and 6 below the sinusoidal axis. So here we're at 2. All right, so let's go up 6. So 1, 2, 3, 4, 5, 6, which puts us at 8. And let's go down 6. 1, 2, 3, 4, 5, 6, which puts us at -4. Draw in your dotted horizontal lines, just to remind yourself that that's where our high and low points of our cosine curve are going to be. All right, next step, let's find a starting point. So to find the starting point, you're going to look inside our parentheses there. So it's x minus 3, which means we're going 3 to the right, which might be a little weird for you guys at first, because you're so used to it being like a pi or pi over 2, but just kind of be open, just go with it. 3, great. Now again, cosine starts at a high point. So you know that our starting point is going to be up here on our upper bound. Now, where are we going to end? We don't know. That's what we're going to figure out next. So step 4 is to find the period. You know, period is equal to, in this case, it's going to be 2 pi, because we're in radians, over b. Well, 2 pi over the absolute value of b. b is pi over 4. So pi over 4. So what do you do here? Move that up. So we have 2 pi times 4, which is 8 pi over pi. Bye-bye pi, they divide out, and we have 8. So we start at 3. We're going to end at 8 from 3. So 8 plus 3 is 11. Okay, and again, we're going to stop at a high point as well, because it's going to go one full cycle. Okay, from here, it's just time to figure out what is going on in between. So halfway between our 2 high points, we're going to have a low point. So what's going on there? Okay, well, halfway between 11 and 3 is what? Okay, so you're subtracting 8 from there. So we're going 4 in either direction. Okay, obviously you guys can eyeball ones like this. When it's more complicated, then you might need to actually do the math, which is why I'm showing you. All right, and now halfway in between, so this is halfway between the 2 high points, and now halfway between, again, the high and the low point. So between 3 and 7, obviously that's going to be a 5. Oh, and you know what? I got all excited. I didn't even draw in my low point. There we go. Low point at 7. And now it's time to figure out where it crosses the sinusoidal axis. Well, halfway between and halfway between. Last step is just to connect it all together. Which color should I pick? Purple. Okay. So try to make it smooth. It's kind of weird on the computer. All right, and then continue it down. All right, and that is it for cosine. Okay, so I'm going to, at this point, I'm going to stop this video, and then I'm going to make a separate video for sine. That way, if you guys have questions going back to it, you don't have to watch, 13 minutes of cosine in order to get to a sine graph. So if you want, well, you should, for sure, go ahead then and click on the sine one and look at that as well. Okay, signing off.